So in this video, I would be covering data structures mainly hash tables and red-black trees. So to start with hash tables, hash table is used to implement a map, and a map here is basically a abstract data type that stores key value pairs. And you can use association lists, which is literally a pair list, or an array to implement a map. But here I would want to emphasize that hash tables are the most efficient way to implement a map. To go over the brief structure of a hash table, it looks like this. So on the left side, you have buckets, and each bucket contains a linked list. So this is how it looks like. And the other main component is called a hash function. And what a hash function does is basically, it's like a regular function where it takes in a key and you do some operation here, and it outputs the index of the bucket. So basically a hash function outputs the location of a certain key value pair to be stored. And of course, there's a good and a bad hash function. To achieve constant time, the hash function has to be good. And the reason is, let's say that you have a hash function fx equals 0. No matter what you put in, it gives out a 0. Then the hash table would look like this. Let's say there's like multiple buckets. Every key value pair would be stored in the first one because the hash function always outputs a 0. And this is 0, 1, 2, 3, 4. So index the buckets. And so if you add 5 elements, it would look like this. And if you're trying to look up one element, you would have to search just this bucket, and the time performance for lookup would be no better than just a regular linked list. So the hash function would not have a constant lookup time. In order to achieve constant lookup time, you have to make sure each bucket is storing a constant C number of elements. That is not proportional to the total number of elements. A good hash function for storing 4 different keys indexed from 0 to 4. Let's say these are the key value pairs you're trying to store. This is the key. This is some random string. I don't know. Then a good hash function for this would be fx equals x mod 4. This way, this would get assigned to the first bucket. This gets added to the second, third, and fourth. So you see how like one bucket stores one element. So with a good, under the assumption that we have a good hash function, the hash table uh, has a constant lookup runtime efficiency. And when we were programming, we really can't know the final size of the total element we're trying to add. So that it's like an arbitrary number. So once you keep on adding elements, even with a good hash function, this um, could, like, the number of elements stored in each bucket could become proportional to the total number of elements you're trying to add. And in order to prevent, and that would result in a linear lookup time (ON). And in order to prevent that, there's a thing called a load factor. And a load factor is basically number of elements you're trying to add over number of buckets. And so usually when this load factor reaches 2, or it gets bigger than 2, that's when we resize the hash table and increase the number of buckets by a factor of 2. So you increase the size of the bucket by times 2. And that way we could ensure the number of elements being added to each bucket doesn't increase with the total number of elements you're adding, and it stays constant. In this case, it would be 2. So like each bucket would store the load factor or less. And that's how the hash table achieves a constant lookup time. And you might say like you should go through all the array to find the correct index of the bucket. But since this is an array, you could just it's a constant lookup time. So like since it's an array, in order to get the, let's say there's 4 elements, in order to get the last element, and let's call this array M, you could just do M dot 2 0 1 2 M dot 3 to get the last element. So it's constant time. You don't have to loop through all the elements.